Alright, time to play Mad Libs. But not the boring kind. We're not just going to fill in all of these lines with poop and fart. Instead, let's do it with physics. Surprise! There's our answers. Car's acceleration is 5 meters per second squared. That means the car's velocity increases by 5 meters per second every second of time. Next, we have a car going from 0 to 60 in 4 seconds. This means the car's velocity is increased by 15 meters per second every second of time. 15 meters per second every second. Car's acceleration is 15 meters per second squared. Then finally we have the penny falling at an acceleration of 10 meters per second squared. If the penny is dropped from the Empire State Building, the penny's velocity increases by 10 meters per second every second of time. Hopefully this gave you a chance to remember that things in free fall 10 meters per second, and you remembered what a preposition was and an indefinite adjective. Some bonus learning here today in physics class. Write two almost identical sentences using the words rate of change for velocity. Velocity is the rate of change of position. For example, if we say we go 30 meters per second, then that means every second our position is changing by 30 meters. Meanwhile, acceleration is a rate of change of velocity. So if we go 30 meters per second or per second squared, then that means every second that goes by, our velocity is changing by 30 meters per second. So a motion diagram without arrows for the following two situations. An object with a positive acceleration. So without arrows, it's going to look like this. Right, every dot represents a second. So two things that this object could be doing. Well, it depends. If we are moving to the right, then we can tell that we are speeding up. Meanwhile, if we are going to the left, we would be slowing down. That's why when you use motion diagrams, it's so important to put in those velocity vectors, include arrows with a proportional velocity vector included. So next we've got, if an object has negative acceleration, so an object having negative acceleration, what two things could this object be doing? Well, again, if we are going to the right, we are slowing down. If we're going to the left, we are speeding up. Easy, right? Velocity versus time for constant acceleration. Well, we know that the slope of velocity versus time is yes, acceleration. So that means our slope should be constant. It's not changing. Any point on this line is going to be the same. So slope is acceleration. That is why. The slope of a velocity versus time graph is acceleration. The slope of a position versus time graph is velocity. Explain free fall. So to explain free fall, all you really have to know is the only force acting on an object, no matter what that object is doing, has to be gravity. So if an object is flying through the air, then, no, not eraser. So let's say we're flying through the air. At any point on this trajectory, the only force acting, if air resistance is negligible, is going to be gravity. So therefore this object would be in free fall. If I throw something up when it gets to the top, so this is going upwards, so this is in free fall at every single point along this. And then when it comes back down, now, well, what forces are acting? Just gravity, also in free fall. What is the acceleration for objects in free fall? So the acceleration due to gravity is 9.81 meters per second squared. And this is based on average across the Earth. But that's kind of annoying to plug into a calculator, so we're going to say it's about 10. Okay, so that's going to make your calculations easier. I prefer, if you are working on a free response question, a question that requires actual numbers and you're writing it out, to use the 9.8 or 9.81. However, as long as you write somewhere that g equals 10 meters per second squared, including units, then that will cover your bases on all questions. All right, for this last test your understanding, we've got a person throwing a ball upward near the edge of a building. We're ignoring air resistance, and we're using g equals 10 meters per second squared. The first white dot is the position of the ball when it leaves the thrower's hand. Each white dot after that represents the ball's position every second after the ball leaves the thrower's hand. In the table below, the time represents how many seconds the ball leaves the thrower's hand. Pause this, fill in the speed, velocity, and acceleration for each. Okay, so here the speed is filled in. As you see, the speed is decreasing on the way up. So it's slowing, stops at the top after 2 seconds, and then it starts speeding up downwards. Can you fill in velocity? Well, velocity is just speed with a direction. So there we go. There's our directions. Positive is in the up direction, negative is in the down direction. Meanwhile, whether it's going up or down, the acceleration is always going to be negative 10 meters per second squared. Negative because, again, down. During which time interval is the object in free fall? Well, if the whole thing is 5 seconds, it's going to be 0 to 5 seconds. It's the entire thing. Get out of my way. When the ball is at the highest point, what do we know for sure about the velocity? Sorry for the crude editing, but when the ball is at the highest point, we know for sure the velocity is 0. It stops at the very top for a very brief. Every second, the ball's velocity decreases by 10 meters per second. Right? So even though we pass 0 and we're getting bigger negative numbers, that still indicates that the velocity is decreasing because we're taking into account that negative. Now the speed is almost the same as velocity, except there are signs or directions. That's what velocity is, a vector. Alright, so we've already filled in the ball's acceleration, and we saw that it was negative 10 meters per second squared at every point along the trajectory. So how does the ball's acceleration vary with time? It don't. Sorry, English teachers, but I gave you an indefinite adjective earlier. Alright, so your hint to explain how the height of the building can be found is going to be that same formula we dealt with in Unit 1. V equals d over t. Or V equals your displacement over time. In this case, the displacement is in the y direction. Here it is all laid out for you, all solved. Remember, this is for the average velocity. So the average velocity, when you go back, add them all up, divide by 5, you get negative 5. And then our total time elapsed was 5 seconds. So that gives us a negative 25 meters. So that means anytime you are going down, you will have a negative displacement. Our velocity versus time graph for this situation will look like this, with a negative 10 meters per second squared slope. We're slowing, stop, changing directions, and then speeding up in the opposite direction.